Good evening, guys. Thank you for joining in. So, how's your day going? I am your host for today. My name is Ruchir Rana. I am product specialist at Skillvertex. Let me know, guys, if you guys can hear me loud and clear. Okay, great. So, we'll wait for others to join. Till then, we can talk. So, can you guys tell me brief about yourself, like what you guys do or what you guys doing, like studying or doing job or particular interest in data science or something? You can type in if you want. Hi, Bhupendra. How's your day going so far? We are waiting for others to join. Till then, we can talk about data science and today's session and all. So you can ask me anything if you want. I am your host, Future. I am a product specialist at Skillvertex. So, hi, hi, Akash.
Hi, Richard.
We are just waiting on others to join and just for some time.
All right, yeah.
Good evening, guys. How's your day going so far? If you guys can hear me clear and loud, just give me heads up in the chat. Let's make this session interactive, right? So we can communicate two ways and make it more interesting.
Yes, you're audible clearly, Richard.
Okay, fine. So I will give brief about me. I am a product specialist at Skillvertex. So I am your host for today. We have Akash Maurya, who is going to take today's session on polynomial regression. So Akash Maurya is having several years of experience in data science. He's currently a data science consultant at Deloitte. So he will be giving you all a brief insight into data science, how things are in the world of data science. And today's specific topic is a continuation of our series on this masterclass. So we will be continuing from our previous session, and you guys can definitely share this session with your friends. Also, let them also join the session. So this session is going to be interesting and insightful. So Akash is going to make this session as interesting as you can imagine. So it this session is going to be fun. You are going to learn something new, and is it, guys? Be be active. Pay attention to whatever details Akash is providing to you. So over to you, Akash. It's already 7.
Yeah. Thank you so much. Thank you so much, Ruchir, for this lovely introduction. Let's start this topic. So basically, as we can see that this is a continuation of the webinar that we have been doing since the last couple of months. So in the last couple of webinars, we have been discussing about the regression problems, right? We have been seeing several example of regression analysis, what are the use cases of the regression problems and all. In this particular session, I'll be actually going through, walk you through the, polynomial regression. So in the couple of sessions before this, we have seen linear regression and the multiple linear regression. How can you exactly use the real life data to do the regression analysis, right? So for example, I'll just have a quick recap of what exactly is a regression, and then we'll move into the today's topic, which is nothing but the multiple linear regression. The polynomial regression, right? And again, guys, so make this webinar two-way, not just one way. I must not be the only one speaking here. If you have any questions, then definitely ask it. You can put in the chat section as well. You can put or you can raise your hand, and I'll allow you to unmute yourself, and then you can also ask your questions like that as well. Okay, so and definitely if you give any questions meanwhile in between in the chat, I will be definitely looking into that instantaneously, right? So let's understand. I'll start sharing my screen, and then we can go ahead with this one. Okay. All right. So as in as the previous webinars, we have been seeing that first I will go through the this particular I would say the theory behind it, the maths and stats behind that, and then I will go through the next thing, which is simply the coding, right? So in this session, so in the previous 2 sessions, I have been actually using the multiple linear regression and linear regression with the help of from scratch implementation and with the help of library implementation as well. This session is again going to be library implementation, because I have already written the codes for you guys. So both the ways, I have also written the code from scratch without libraries as well, without the sklearn itself, and I have also written the the code with the library itself. So let's understand this regression first, and then polynomial regression to make this class interactive. And to make this class interactive, again, I would ask you guys to, if you have any doubt, any clarification, you can simply let us know in the chat, or you can raise your hand itself. So I hope you guys can see the screen, right? So I think this is the this is what we had seen in the last session. So let's continue from here itself. Okay, so I'll begin from here. Let's say what exactly is a regression again. So if I go here, if I go to the linear regression, so for example, if I have a data, right, and I have a data and I have a particular trend on the data, so I want to simply see what exactly is the trend, and I just want to simply build a line on that data, right? So for example, I have an x-axis, I have a y-axis, I have salary data, I have experience data. So if I want to predict the salary based on the given experience, so I can simply plot it, and then based on that, I can simply draw a line if there is a linear trend on that, right? If there is a linear trend on that, so I will be able to draw a line. Now that line will be nothing but my linear regression model, right? So again, let's say if the salary is like this and experience is like this, and there is a linear relationship between these two, then I can simply make a line to make my model happen, to make my model work, right? Instead of this, let's say if these two features does not have any linear relationship, right? Instead of that, let's say if they have polynomial relationship, and when I say polynomial relationship, that means it is not linear, but it is actually having a zigzag. Let me just draw that, and then you'll be able to understand that better maybe. So let's say I have these data points, right? Okay, so let's say this kind of a data if you have, and then simply you can also build a linear regression model on this as well. You can also fit a line that follows the data. If you see there is an overall uptrend in the data, right? Now, if you just see, if you want to create a line, remember in one of the previous session, I had told you the concept of error. What exactly is the error? The difference between the predicted value and the actual value. Since this line represents y hat is equals to mx plus c, which is nothing but w1x plus w0, right? So that means this y hat is a predicted. So any value, let's say I want to predict for this particular x, so the actual value and the predicted value. So this particular x, the actual value is here, y, and this y hat is the predicted value on the line, and this difference is called error, right? And the more data is deviating from the, the more data is deviating from the line, it is having more error in this, right? Since I have this line, now it is, if you see, it is actually capturing the uptrend in the data, but it is not able to, I would say, fit this data very, very well, because there is a huge amount, there are some huge amount of errors in this. Now, if I, instead of this particular data, if I create a curve on this, right? If I create a curve on this instead of this particular instead of this particular line, let's say the curve goes like this. All right. Now tell me which one is better in terms of fitting the line. Like let's say the curve 1, the line 1, or the curve 2. Which one is better in this case? You can answer your question in the chat. So Deepak says it is 2, right? So it is 2, and that is the reason, right? This is the reason. I mean, what is the reason behind that? The reason behind that is because it has less amount of error. And why will it have less amount of errors? Because it is passing through most of the data points. Like it is passing closer to most of the data points as compared to the line, right? I may create another curve that may and may not pass and may be closer. So in that case, I'll have to calculate the error. There are various types of error that we can use actually. First one is the, we had seen example of various kind of errors. Like first evaluation criteria is the, let's say, absolute error, which is basically the, the absolute difference between y and y hat, and summation for all the points I is equals to 0 to n. And similarly, the squared error is same thing, y minus y hat whole square, right? Same summation here as well for all the points that we have. And then we can also have mean absolute error and mean squared error, where we just divide this whole thing by the number of data points. So we'll get the error per point. So in the case of absolute error, we'll get the absolute error per point. In the case of squared error, we'll get the squared error per point. What is the mean squared error? I mean, squared error per point, right? And similarly, in order to make the squared error to the real range, we can also take a root of that, and then we can take a mean of that. So that is also called root mean squared error, which we also represent as RMSE. Other than that, we also have a metric called R2 score. So if any one of you from that lecture, if you have seen that particular lecture, that particular webinar, you might see that R2 score is another value that gives you value in the range of 0 and 1, right? In the range of 0 and 1. So 1 being the best value and 0 being the worst value. There are some conditions as well where you will get the less value than 0 as well. So I mean, do not think about that. So in this case, let's say when you give when we are closer to 1 means that you have predicted exactly same value for all the points, right? So they like all the like your curve is going through all the data point exactly same. Curve is actually going through all the data points. So then you will get the R2 score of 1, and that is not possible in the real life scenario. We just want to generalize our model, not to specify this, right? Maybe in upcoming session, I mean, in one of the session, we also have understood the, we have also understood the idea of overfitting and underfitting as well, which is basically derived from this polynomial regression. If you just have a very high polynomial regression, means very high degree of polynomial, then it will try to catch up, all the points like this. So I'll just want to, it just will try to actually go through all the point that is given here. And that is really not good, in skills. What it will do, it is try to specify all the data points other than just generalizing and moving smoothly towards the data point. So this will be a really, really bad way to begin with, right? So that is called the I would say, sorry, that is called the overfitted model, right? That is called the overfitted model. Now let's start with this. Now say, why did we actually went through the polynomial regression? Is that our linear relationship is not there, right? If we create a line, if we want to fit a line, then it will have a more error as compared to the polynomial regression. Now how can we actually create the polynomial regression? Now how many of you were present? So that is why, see, I have actually done in this session, I have already done few topics related to previous like polynomial regression and even overfitting, underfitting. I've also done the linear regression. So if you guys are feeling something like you are not able to understand it properly, that is that is because you guys do not have maybe the prior knowledge that we have already discussed, the prior things that we have already discussed. So if you have a proper basic knowledge of this, then you'll be able to grasp 100% of this lecture. Let's say if you anyhow miss the chance to actually understand this better. So what you can do is, we are actually launching one master class, basically with the collaboration with IIT Roorkee, that will start in a month or two. And in there, we will be starting from the very basics, starting from Python, and anyone who has a very basic knowledge of maths and very basic knowledge of statistics will be able to learn this whole data science course that we are offering. So it is from the very beginning, starting from basics of Python, basics of SQL, basics of data analysis, right? And then we'll go into the machine learning and data science aspect of that as well, right? So this is what we are actually planning. If you want to, just do everything from the basics, at the end of the session, Ruchir will actually explain you how exactly you have to go with that. How can you actually know more about that at the end of the session? So to actually move forward in this particular scenario, the polynomial regression, if you remember back, we have already talked about the multiple linear regression. In multiple linear regression, what exactly happens is, we have multiple features, right? For example, we have x1, we have x2, we have x3, right? Let's say these are the different features. These are input features, right? Let's say if you have different multiple input features and then one output feature, and all of them are continuous numerical values, right? Then we can actually use a multiple linear regression, right? And if the relationship is linear, right? Think about it. What will be the exact equation in this case? The equation is going to be like w1 x1 plus w2 x2 plus w3 x3 plus w0, and this will be nothing but your y hat. So this is the equation of multiple linear regression. Now, why this is a linear regression? Because this is, since there is only the maximum power of x is 1, that is why this is linear regression, right? If the maximum power of x would have been more than 1, then we'd have called it a polynomial regression, right? Because if you remember in calculus back before, in your high school standard or even before, you might have learned about the polynomial and like quadratic equations and polynomial equations and linear equations like that. So basically, if you have a linear equation will always have a degree of 1, and polynomial equations will always have a degree of more than or equal to 2. Right? So that's what we call polynomial equations, right? So let's see, this is what we have. Let's say if I have I'm just comparing two scenarios. Let's say I have one feature here, x, and one y output here. In this case, if I have to create a polynomial regression, so how will I do? So first thing that I will do is I will create new features with the help of just one feature that we have. What we call it? We call it poly-feature transformation. Poly-feature transformation. So what is poly-feature transformation? So we are actually transforming our features with the help of polynomial feature. We are actually using polynomial features for this x value that we have. So instead of just having x, what we'll have? We'll have 1, like we'll have x power 0, we'll have x power 1, we'll have x power 2, like that. We can also have like x power 3 as well. So let's say if I'm having 3-degree polynomial, then my x is going to be changed from this 1x to this, right? Let's remove this because x power 1, 0, we always have, it's nothing but 1. X power 0 is nothing but simple 1, right? So this is what we have. Okay, we have x power 1, x power 2, x power 3, x power 1 is nothing but x, and then we have 1y. So tell me, just tell me, isn't it very similar to this particular thing? Instead of here we have x1, x2, x3, these are the different features. Let's say call it ABC. We can also make it ABC, right, as well, ABC. And this here we have W0 plus A W1 plus B W2 plus C W3, like that. Exactly same thing, right? Now instead of this ABC, if I write x square and x cube, so what equation will we get in this case? So we will get y hat is equals to W0 plus W1x. Instead of A, I'll just write x power 1 or x, and then W2 x square plus W3 x cube. If you see, this is nothing but a simple polynomial regression. Right? This is nothing but a simple polynomial regression. So instead of having just one feature, you converted them into polynomial features, multiple polynomial features, and then you just simply applied linear regression on those multiple features. Right? You just had one feature. For example, you have values like 1, 2, 3. So here we'll get 1, 2, 3. Here you will get 1, 4, 6. Here you will get 1, 8, and 27. Sorry, not 6. Here you will get 9. Here you will get 1, 8, and 27. Like that. And what you have to do, just think about it as independent features and then apply multiple linear regression on top of it. Then you will get a simple polynomial regression. We understood two things here. Why do we use polynomial regression? Because linear relationship is not capable enough to capture all the twists and turns in the data. That's why we are trying to apply multiple polynomial regression here, because polynomial regression will allow us to turn in the data, to make the turns in the curve, right? I'll also come to that. And again, you already know the multiple linear regression and how we have to actually apply in the code itself. First, we have one feature, and then we will try to apply poly feature transformation, and then we can apply simple linear regression. This is nothing but the linear regression. And then that resultant will be a polynomial regression, right? So if I write here that poly feature transformation plus linear regression or multiple linear regression plus multiple linear regression is equals to nothing but the polynomial regression. Okay, so this is nothing but the simple polynomial regression. So this is how we actually this is how we exactly do the polynomial regression. Now you saw also the math part behind it as well. You also saw the how do we implement it, right? We'll also be actually following the similar way while implementing the coding as well. You also saw how do we do it. Now remember one thing I just told you, that how do you actually identify that by adding it or making a polynomial value, we'll be able to actually have the twists and turns in the data. So how many of you, those who have learned the calculus in your early days really well, they might be remembering there is something called critical points. In any curve, in any curve that we have a critical point. Do anyone know what is critical point in polynomial equations or curves? Anyone of you? I'm hoping some answers in the chat, maybe. Critical points. So I'll just try to explain that. Meanwhile, you can tell me. I remember the term, but forgot what it was. Okay, no problem. I'll just explain that. Okay, see what is critical point. So let's say I have a curve. Okay, let's say I have a curve like this. Right. So this is a parabola. This is a simple parabola. Now, critical point is where the curve changes its direction. So if you see, or we can also say where its tangent is parallel to the x-axis, or where dy by dx is equals to 0. So if you see here, or d2y, I think d2y by d2x upon dy is equals to 0, I guess. Yeah. So here, this is the critical point on the curve. Right? So this point here, where the tangent is equals to parallel to x-axis. Okay, that is called critical points. Now remember, critical point is where the curve changes its direction. So let's say if I have a curve like this, let's say if I have a curve like this, then it will have two critical points, one here, one here. Similarly, you just have to understand how many twists, how many turns it is making, those many critical points will it have, right? Do not, I'm not talking about this particular critical points. Okay, actually the critical points are going to be somewhere here. Okay, remember the tangent should be parallel to the x-axis. In maxima, minima, asymptotic notation, yeah, that's correct. That's correct. So here we can simply find out the maxima, minima. If in simply d2 of x divided by dy du. So if you can calculate this, and if it is 0, so you can simply calculate maxima, minima with the help of that. When you equate it to 0, and then you can calculate the maxima, minima with the help of that of any function, right? So this is that similar thing, right? So now, so remember here, if you notice it, so you can see any parabola has has only one critical point. Parabola has one critical point, and how many what is the degree of the equation of a parabola? Can anyone tell me what is the degree of equation of a parabola? It's a simple thing, you must know that. Quadratic, exactly, it's a 2. That's correct, right? Degree will be 2. Now if you see, there is a trend, right? If you have a 3-degree polynomial, right, then it will have a 2 critical points and 2 turns into there. Then critical points are going to be 2. So basically, by understanding this, you can understand how you have to fit the model, by what polynomial equation you have to fit the model. Okay, so this is a very critical thing that you have to understand. Now let's say you see a data like this, right? Let's say you see the data like this, then the model that you are going to create with this, that should have how many critical points? 1, 2, 3. To achieve critical points, 3 critical points, what should be the minimum degree of model, minimum degree of your model? To achieve 3 critical points, what should be the minimum degree of model? We just draw a relationship between degree of models and critical points, right? Let me just show you here. To achieve 3 critical points, the degree of model should be what? 4. Okay, 3 critical points mean 3 turns. In order to make 3 turns, the degree of model should be 4, means x power 4 should be there. That's correct. That's great. Now, this is what exactly we are doing here. Now, when we will be actually, see, by looking into the data, eventually, if you have just a single parameter, then you can do that. Otherwise, if you have multiple parameters, then we have nothing. Just we can simply do the hit and trial method, right? There is nothing else that we can other than that, right? But if you have one parameter, then simply you can actually see the relationship in the data, and you can simply understand how many what exactly do we need. And that also depends on how, what error do you want from the model, like what error is your reasonable error that you can work with, right? So that is also one of the point. So when you actually train machine learning models, when you train a lot of and fine tune a lot of machine learning models, then actually you'll learn this art that to actually do the trade-off between the error and the complexity of the model. You cannot increase the complexity of the model because that will be an overfitted model, and that will also take more time and more resources. That so basis what time you have and how much error is reasonable, then you can actually decide what should be the complexity of the model, right? If you can decide it with other mathematical way like this, if your data is very simple and you can see simply how many twists and turns are there, then you can also decide the degree of the model. But even if your data had 3 critical points, right, if you simply see here, then remember I told you one pattern here that this should be minimum degree of model. Minimum degree of model should be 4, but not less than 4. You can also have more than 4, that's fine. Like you can have 5, 6. You cannot go much higher than that, like 10, 12, 15, 20, like that. You cannot go like that much higher, but definitely you can go a little bit higher, like 4, 5, 6, 7, like that you can go, depending upon how much data do you have, right? So this is the whole maths. And if you have any question regarding this math, you can tell me. Otherwise, I'll just move to the coding implementation of this particular thing. Any question from anyone as of now? I'll just quickly open the code for this. So I've already written code. Actually, this is my day-to-day task. Every month I have to go to the same thing. Everything is clear. That's great. I have already the code. I'll just run it in front of you and tell you how can you actually begin with this. Okay. So I'll just share a different screen. 1 second. All right. I hope you guys can see this. I'm going to open. So this is actually a Jupyter notebook. You can install with the help of Anaconda Navigator. You can install Anaconda and then you can install Jupyter Notebook. Here you can write Python codes inside it, right? So I already have this, Skillvertex, a lot of classes going on. So let's say if I go to my last batch, let's say August or September, maybe, and from here I'll tell you the polynomial regression. There are various, like this is the polynomial regression from scratch. So if you see here, what I'm trying to do, this is a function, let's say sine function, and this is the polynomial equation that we are going to do. And here, let's see, everything you will see as a function. So for example, this is a function to generate the data, right? Let's say in this function, I'm actually doing, let's say till 0 to 2 pi, I'm generating the data from 0 to 2 pi. If you see this is a 1 period from 0 to 2 pi, and this is a sine curve, right? Now, based on this data, let's say this data we have, this is the input data that we have. I'm just fabricating, I'm creating my own data set. Okay, I'm not using any real life data. In the next example, I'll tell you to use the real life data. Okay. Just 1 second.
Recording in progress.
Sorry. All right. Okay. So let's start with this. So yeah, I was saying that let's say we have 0 to 2 pi the range of the data, the range of the data, and now this data I'll try to fit with the help of my polynomial regression model. So let's say this is the model that we have created, right? Let's say this is the model, and if you see, there are the functions. So basically this function, what this function does, this function do this task. Remember I told you the polynomial feature transformation, this function exactly does that task, right? So this is the function that does this, and basically transform one features to multiple features. Let's say this is x power 0, this is x power 1, and this is x power 2. X power 0 means nothing but the 1 1 1 1 you will get. You will get an area of 1 1 1 1, all 1 values in there, right? And this is x power 1 and this is x power 2, just squaring the value. Now we can simply multiply that with the help of the weights that we have. So for example, I'll just tell you one simple example of that. Let's say let's say if I have, let's say this particular thing here, and then I have the corresponding weights, right? Sorry. Okay, let's say we also have the corresponding weight. If I do the vector multiplication, let's say W1, W2, W3, and so on. So we can simply get like W1 multiplied by 1. So we'll get W1 plus, or let's call it W0 here, W0, W1, and W2. So W1 multiplied by, W0 multiplied by 1 plus, and so it will be W1, this will be X. So W1 X plus W2 X2, if I call it X2 or X square, right? So instead of it will be X square. So this is nothing but our equation that I was talking about. So if you just multiply this for this value, you will get what? 1 like Y1 hat. Similarly, for the next value, if you multiply, you will get W1 plus W1 X1. Let's say this is X1, X1 power and X power 2. This is X1, X2 power 1 plus W2 X2 power 2, like that. Then that will be nothing but Y hat 2. Similarly, for all the x's that you will have, you will get a Y hat. Y hat is nothing but our predicted value. And then we can actually calculate our, errors and all, whatever you want to do. And then you can update the weight. So this is how exactly we do it. Okay. So we just have to simply, I was just telling you the maths behind implementing this machine learning algorithm when we multiply this, right? So here, this is a function to initialize the weight. This is a function to predict, means we are simply doing the matrix multiplication here. See, remember that just the thing that I just explained you on the screen, exactly same thing I'm doing here on the code. I am just doing the matrix multiplication and calculating the Y hat, the series of Y hat, the array of Y hat. So everything here that is being done on the array perspective, right? Not a single value perspective, but array perspective. So everything like this is an array. This is not a single value. This is not a single value. A is not a single value. W is not a single value. All of them are array. Here I'm calculating this. So this is also an array, right? And then here I'm calculating the delta W. So those who already understand the linear regression, so I'm actually using here the gradient descent, model. So there you have to calculate delta value, delta W, and then you have to, have the learning rates and all. So again, I cannot go and explain the whole thing that we have already explained in the gradient descent, right? Because we have a limited time here, and basically that we had already covered in one of our other webinars. So again, I'm telling you that if you find this, lesson very interesting and you're keen to understand the whole thing from scratch, then definitely you can join our webinar that we are going to have in the next, 1 or 2 months, in collaboration with IIT Roorkee. And as I said again, we have actually, collaborated in such a way that we have designed our the course in such a way that even if you have a very basic knowledge of maths and stats, you can actually learn the data science from the very beginning. So I'll be starting from Python so that you can understand the code as well. I'll be starting with the basic math. I'll be starting with the basic statistics and basic SQL programming language and everything. Since you once you have a basic knowledge, then you can actually move towards the higher end machine learning and deep learning maybe, and then the data science part of that as well, data science and data analytics part of that. So this is how we do it. And let's say I'm actually creating these functions and running these functions. So see, as of now, I'm just simply creating the function. So this function initialize the weights, this functions predict the values, this function compute the last function, this functions calculate the delta W's, and this function update the weights. So if you remember the gradient descent process, so we actually do the exactly same thing. Now here this function actually trains the value. So all the functions that we have already created here will be using in here. So in the gradient descent process, first thing that we actually predict, calculate the loss. Based on that, we'll calculate the delta W, and based on that, we'll update the weight. So we'll initialize the weight first, random initialization of the weights, and then based on the learning rate and everything, we will be actually updating the weights that we have. Now, once we have updated the weights, then we can, this is the function. Now let's see how do we run it. So we have a number of, number of elements, how many number of data points that we have, and then what is the degree of the model. Everything is here itself. And this is the eta. Eta is nothing but the learning rate, and how many epochs. Epochs is nothing but how many times the same algorithm will keep running. This is nothing but the gradient descent approximation algorithm, which will approximate the value of W0. So W0 and W1. So whatever weights that we have, W0, W1, W2, how many weights we have, it will approximate the values for all those W's, right? So if you increase the complexity, the W will be increased, and our computation cost will also increase because we have to approximate those many values then, right? So again, here we are simply doing this. This is the initialize, and then here we are generating the weights and generating the W's, and here we are simply calculating the now the W's, training them, and then here you can see this is how we have done. Now, if you see the data that we have, I am implementing a 4-degree polynomial. If you see, this data is only having this data only have two curves. Two curves means 3-degree polynomial is enough for this. So let's try to implement 3-degree polynomial and see what we get. Even 4-degree polynomial will not give us bad result. So if you do it multiple times, actually you'll understand this. See, it is not working fine here. I'll tell you the reason behind it. It is not working because actually we have a less data, right? So let's increase, or there might be also a thing that we have a less number of epochs. Let's try to increase the number of epochs. You can see now it is trying to actually move towards that. And even if we, let's say, decrease the epoch, but we increase the data set, let's say, then even it will work. You can see when we increase the data set, this become dense, like there are more data set in just this, and then it has become much closer to the actual point, right? Let's say if we increase the epoch again, then you will see that it is like almost perfect, just going just exactly similar to this point. So we are just able to create the curve based on the polynomial regression. Let's say if I increase the 0 to 2 pi, I'm just having 0 to 3 pi. Now my data will have 3 critical points. Then tell me, what should I keep the value of degree here, the minimum value of degree? What should be that? Now again, exactly similar question that previously I've asked for. Exactly, it should be 4, right? Because there are 3 critical points, so then we'll have to put minimum degree of model would be 4. If I, let's say, make 3, see what will happen in that case. Since we have a huge amount of data, 500 data points, so we are getting like this. It is trying to approximate within this. But if we just make it 4, see what will happen. See, it is just now able to approximate it. Even if I make it 5 or 6, it will not deviate a lot, I guess. Okay, there is a problem actually. We are getting null value here in the training. There is a problem called something called the gradient exploding. That is what it is happening here. Here again, gradient exploding. Let's see here. Yep, let's try to see. See, now it is actually trying to do, but again, this is not ideal. If I make it 5, let's see what happens. Now you can see even on 5, it is working fine. So you can, just 1 or 2 degree polynomial, you can increase it. When you have a real life understandable data, then you can do it. Otherwise, you will have to do heat and trial method. And again, epoch is also something, one parameter subjected to change. Degree is parameter. Number of data points when you're working with the real life models, real life problems, then this is fixed. You cannot change it because you have already fixed data every time. But these are the parameters that you can actually change, right? But you have to understand that more the data you have, better the model will be, right? So this is the degree of the model, and I will basically send you guys this particular notebook, and I will just you guys to do some play around the notebook that I'm showing you here, and try to actually find out different values with the help of these. Okay, so yeah, this is how we actually do. This is again, there are a lot of things that I've already discussed in other webinars, in the previous webinars, which is gradient descent, linear regression, and in the whole process of the coding that we have done actually, right? So that is it. And I've already explained how exactly the curve and how exactly the data that we have and how exactly the polynomial regression works. So if you have understood this, and even though if you're not understanding the code, but you might be understanding the polynomial regression, right? So again, if you understood just the polynomial regression, that is much better. You are more than 90% of the people who understand clearly. So no problem on that. If you want to learn somehow, you want to learn Python programming language, and then you want to learn how exactly we implemented it, then definitely you'll be able to understand, since you have a very high basic knowledge. So with that note, I will say that is it. Okay. If you have any question regarding this webinar that we're having, regarding this particular topic, or even the masterclass that we are going to have, you can fire your questions at us. So that is it for this session, guys. Thank you, everyone. If you have any question, then definitely I'll be happy to answer your queries.
Thank you, Akash. It was very insightful. Guys, you can ask a question in the chat.
Yeah.
Akash will sort your queries.
So when
Okay. So
okay,
Samir. So course details and structure, I'll be coming to that. So if you
okay, I
have
guess,
any question regarding
yeah, if you have any
this,
technical questions, then you can ask it first. What is the benefit of this? That is also related to that course, I guess.
I will address all these queries. Okay. Just if you have any question regarding polynomial regression, you can ask Akash. If not, then we can go about the course structure and details. So you guys can ask him if you have any queries.
I guess that's it. You can go ahead, Richard. Yeah.
So Adil, topic name is polynomial regression. Okay. So I guess there are no queries then. Okay, so I will walk you guys through the details. Sorry guys, it was internet issue. No worries, I'm back. So there are a lot of queries regarding the course structure. Let's just address that. So
There is one question, I guess,
yes.
related to that. I already know Python and basic list making arrays, so can skip Python part. So, Sameer, I would say that Python for machine learning is just not just the core Python that you know, which is the list, tuples, and all the objects and data structures, if else, for loops, and all. Other than that, there are some libraries that you need to know before going to the machine learning and data science, like pandas, numpy, matplotlib for visualization, and for them you just need to have a very good command on the basics of Python itself. So I would say yes, if you have a, I mean, skipping is not possible. Python, skipping the Python for data science machine learning is not possible because there are libraries that you should you have to consider and you have to learn them. And again, I would say as a strong Python foundation you have, you'll be that very good for you guys. So definitely, if you just have a recap, then definitely that will be refreshing and good for you as well. Yeah, you can go ahead, Richard now.
Okay, so I hope you guys enjoyed this session. So this session was a part of our data science education course in association with I have Divya Sampark with IIT Roorkee. So this master session was a part of that course, and this was just a glimpse, and you are going to get more sessions like this. Don't forget to connect to learn more about the data science, because you already know that data science is booming, and how important it is to get your skills certified with certification like this. When IIT name is associated with you, your resume is definitely going to get a boost. So we at Skillvertex, we bring you this data science certification course in association with iHub Divya Sampark with IIT Roorkee. You can just log on to skillvertex.com, and you can just hover around the tab. You will see that data science certification course with IIT Roorkee, and you can find this page. So you can just fill in the basic details, and you can either apply, or you can also download the brochure. What all queries you have, a counselor will connect with you, provide you with all the details, all the help you need regarding the course, right? So I will walk you through what all we have in this course. So this data science executive certification program in data science, you are going to get a very, what I say, renowned certificate with a tag of I have Divya Sampark IIT Roorkee. So in this certification course, you are going to get live sessions by industry mentor. Trust me, they are industry experts, and they are having large amount of experience over the industry, and they are actually solving industrial problems, and they are well known in data science field. So they are going to give you each and every insight in the field of data science, right? So in this particular executive certification course, you are going to get placement assistance as well, and more interviews. We have so many companies associated with us. So not to worry about, you get yourself skilled, and we will help you to get placed in your dream company. So it's a 6 months month program, and in case you have any doubts or something, our mentor will help you out so that you don't miss out any learning opportunity. So this is how certificate look like. So this will definitely going to add some value in your resume. So you can also download the brochure and go through the details by yourself. I am just going you a brief overview that how and what things are included, how the program is going to get, right? So this is all the details that what all things I have Divya Sampark IIT Roorkee is innovating and enabling. So these are the job everything. So what you can become after the certification, right? So you have, so once you complete the certification, you have successfully completed the course, you can become a data scientist, data analyst, big data engineer, machine learning engineer, business analyst, right? So there are so many opportunities out there in the market for you to, explore with this certification course. So it will also open so many doors for you to venture into the market. All right. So these are the companies that are currently looking for the data scientists. So I know these companies might be your dream companies. So once you get skilled up, you are certified with us, you can definitely get a chance to work in these companies by yourself, because we are going to make you market ready, and you are going to get hands-on experience about how data science field is in the industry, not just theoretical knowledge, but we are going to give you the projects and minor major projects and assignments which give you insight in the industry, and you actually solve some problems, right? So here it is curriculum. You can see this curriculum is very diverse and inclusive of all the necessary skills a data scientist need to have, such as SQL, Python, machine learning, right? Deep learning, NLP. These are buzzwords, and they are currently into the market. They are this is what skills recruiters are looking for currently, and industry is venturing into. So we are going to give you the best skill for the data science field, and as a data scientist, you are going to nurture these skills into yourself and become a great data scientist. So here, these are the module details. I'll not go into the details. Uh, right. So here are some of the projects, like how Amazon product recommendation works, taxi demand prediction, right? Quora suggestions. So these are type of projects which you are going to learn and complete. So you are going to get insight into the actual how companies are working, and you can also innovate by yourself, right? So here are the tools. So you are going to learn each and every tool that are required by the industry. So by the end of this course, you will be ready. You will be industry ready, if I say, with all the necessary tools at your disposal, right? So this is it. Here are some of our alumni's review about us. So you can definitely join the course. Courses start from 5th of every month. So you can definitely enroll. So it is already 13, but you can still enroll for the next batch. And this course is not only going to give you the skill, but it will make you market get ready, right? So if you have any question regarding the course structure or anything, you can hit me in the chat. It would be, yeah. You can ask me anything, guys. Feel feel free to ask me anything. I hope you guys enjoyed the session. You understood about the course structure, right? So Samir, course will start 5th of every month. Like now, this course will start on 5th of November. So you can enroll for the November batch. Yeah, thank you, Samir. Anyone else have any kind of questions? Just hit me up. I would be happy to answer your any of your queries. Just hit me up, guys. Okay, then if you guys do not have any queries, then we can round this up. If anyone has any queries, then just let me know. I guess there are no queries. Okay, guys. Thank you so much for joining in. You can also share this session with your friends. We are also live at our YouTube channel. You can also search for the Skillvertex YouTube channel. In case you have missed any of the content, you can watch it there. So you can find it over Skillvertex YouTube channel itself. So thank you so much, guys. It was really wonderful session, and thank you so much for connecting. Please do not forget to connect in upcoming master classes as well. Our mentor will continue providing you the insight into the data science, and you're going to learn things about polynomial regressions and other things, right? So please join the next session as well. It will help you in your data scientist journey. Thank you so much, guys, for connecting. We'll see you in the next masterclass. Till then, take care. Good night, guys. Thank you.